Hi, welcome to this module on intermediate Java. And the reason for this module is because there's a whole lot of Java code out there. Okay, billions of lines of code, and you're going to be looking at a lot of code from a lot of different places throughout the semester, and as you go on and do other development in Java. And the problem with looking at other code is that sometimes it's written not that well. Okay, and doesn't use more modern constructs. And so one of the goals of this lecture is to get you started to be familiar with the semi-more modern forms or a few of the constructs of Java that have kind of changed significantly over the years, so that when you run into code that's written using an older style of Java, you won't think that that's the right way to write code. And if you're just starting out to write Java, and you're looking some old textbook or whatever that's not written, correctly or using the modern constructs, you'll know that they're not doing it right and that there's a better way to do it. Okay, so let's get into it. So the kinds of more modern constructs, post Java 5. Now Java's in Java 7 right now. It just 7 just got released, so 5 seems pretty old. It's several years old, but really since Java 5 was the last time that they made really significant changes to the syntax of the language. Java 8, they might start doing some more crazier stuff again, but really Java 5 had a fair amount of stuff that distinguished it from Java, the 4.3.2 and 1 versions of Java. So the things that I want to start talking about today are collection classes, enumerations, generics, for each, control structure, autoboxing, and annotations. And these are all covered in the reading. So this is one of these places where your Java in the Nutshell book is very important to take a look at, because they will go over it in more detail. Also the Effective Java. Effective Java is an excellent book. I have read it cover to cover multiple times. Okay, and if you want to, become, pretty decent at Java, or just gain some, insight, I would really recommend that you spend some time with the book. It's really well written, and it's very interesting, in my humble opinion, to to read about the rationale for the way certain Java constructs are, and kind of the subtleties of the language. And really, you're learning not just about the subtleties of the language, but you're learning about the subtleties of computer science or computer programming, or really the subtleties of design. Okay, and how design interacts with optimization. Okay, so it'll turn out that there are features in Java that seem like needless syntactic cruft, or extra steps you have to go to, and sometimes it's just because they made mistakes in Java, but sometimes it's because in Java they wanted to give you certain controls over the way things would actually execute at runtime. And other languages may get around this by having a more simplistic type structure, or a more simplistic kind of execution environment, or less optimal, okay, than providing the user some level of control over how things work. So it provides you with some insights into, or some capabilities for optimization or control that aren't necessarily possible in more the quote-unquote more dynamic languages. Okay, dynamic languages are pretty cool. There's a lot of good things about it, but they come with costs as well. So I think that this semester, if you're big into Ruby or Python, you might find this semester interesting to you in terms of kind of figuring out, well, I can declare the types of objects in Java with a level of detail, and it actually provides me some benefits that, there's certain kinds of runtime errors that I commonly get in Python that I don't get in Java because it's caught at compile time. You might also be interested in language like Scala, where It eliminates some of the syntactic verbosity of Java, but does type inference in order to get the same level of safety. So it's fascinating as you get into programming languages, the kinds of variations that are possible. So anyway, as I said before, I think you definitely want to be reading the appropriate sections of Java in a nutshell, as well as the chapters in effective Java related to collection classes and defining abstract types and stuff. It's wonderful, that book. So let's start with collections. And the idea is there is this collection class which groups together objects of a given type, the type represented here by E. And a collection is a very general kind of thing. It can have duplicates. It may not have an ordering, and just has a few operations on it. So you can create a collection of strings. You can see here in this top line. And then collection is an abstract class, so we have to implement it by specifying a concrete class as the actual kind of data structure we're going to use. Now one of the fundamental things you need to understand when doing design, okay, and particularly in Java, is that you may not have the same class on the left-hand side as you do on the right-hand side, okay? And when you do that, what it is that you're telling the developer is that any user of this strings object should be limited to only the operations that are available in the collection class, because given the semantics of my domain and the way I'm using things, it wouldn't make sense for a user of this strings object to use all the operations available in the hash set class. Okay, so when you see code like this, you realize that the developer is telling you something about the semantics of this strings object. Okay, the developer is saying, even though I'm going to implement this as a hash set, I want you to think about, and I'm going to demand that you think about this strings object as a collection. And that's a very powerful and very cool capability of the language, in my humble opinion. Okay? So, we can do here's, a couple different definitions, and we can add things to it. We add a bunch of things to it, or we can add one thing to it, we can remove things from it. We can check to see if it's empty or not. So that, there's all kinds of stuff you can do with this collection interface. I'm not sure if it's an interface or an abstract class. I'm sorry, I don't remember offhand. Okay, but there are, sub-interfaces of the collection interface. I guess it's an interface, such as set, where there are no duplicates, sorted set, where there are no duplicates and there is an ordering imposed on the elements of the set. There's a list, which is ordered but can have duplicates, and then there's a map, which is a collection of keys and values. Okay? And there's a whole bunch of other ones as well. All right, so you got stuff to support concurrency. You've got trees. You got a whole variety of collection classes, and so oftentimes in Java, when you are defining some kind of in-memory data structure, okay, most of the time you should be able to get a pretty efficient, pretty fast data structure by using one of the built-in collections, or sometimes there'll be some library that you can import that that provides a a collection that's pretty optimal for your particular situation. It's very rare that you have to kind of custom code your own collections class. Okay, now you may come across code that uses the vector class or uses the hash table class, and if you see that code, and that's legal Java, you can use those classes in in Java 6 or Java 7, but you cannot in this class use those. You'll be marked down if you use them, because they're holdovers for backward compatibility. Okay, so I want you to recognize that the kinds of collections you use are very informative to the future reader of the system, which might be you, about what your design intent was when you were building the system. So if you need to keep a list of strings in alphabetical order, without any duplicates, okay, what kind of collections class would you use? Okay, and I'm going to not answer that, but I'm going to tell you that the code itself can, in this case, kind of be self-documenting. Your choice of collection class can tell the user that that's what you're intending. That there should be this list of strings, they should be held in alphabetical order, and there should not be any duplicates, just by definition of the collection class that you're using to hold these objects, which is pretty cool. Okay? So here's another example. We've got this class called compact disks. There should be instances there should be a collection of these compact disk objects. We should be able to retrieve instances by their title, produce a sorted list by their title, and how would we design this abstract data type? Okay, and this is where Java gets a little bit complicated. What methods do we need to override in order to make this class work correctly? Okay, and so it turns out that when you define collections, okay, that you will need to override equals and hash code, okay, and then sometimes if it's an ordered list, you're going to have to override compare to, okay, and so this is because equals by default, okay, is defined to use instance equality. So are these two objects located in the same place in memory, versus being two objects that have are identical in every way, but they might be located in different places. And then we need to override hash code so that when we have the same object but it's implemented in it's located somewhere differently in memory, that hash code will produce the same integer for them. And then compare to is the method that you want to override in order to make sure that if you're using a sorted collection, that the objects are actually sorted the way that you want them to. Okay? So I'm not going to go into the details of how you do this because it's explained in excruciating detail in the readings, and so that's the better place to spend your time learning about this. I just want to point out to you the importance of being able to do this. Okay, enumerated types are another kind of type that should be in your arsenal, and that's when you have a collection but there's not a whole bunch of things that can go into it. In fact, there's so few things that you can just type them all out and you've got the entire set. And there's there's 20 things, or 5 things, or maybe even 100 things, but not like 25,000 things. Okay, and in advance all the possibilities. So here's an example of declaring it, and the way that the standard in Java is that the enumerated type is capitalized in exactly the same way as a class is, but the elements are capitalized like constants, so they're all uppercase. So here's an example of an enumerated type colors and some sample code that shows how you can fool around with it. Again, they work kind of exactly the way you'd expect an enumerated type to work, and my point here is that you shouldn't be using an array list when that there's only going to be 3 objects ever in this list. Okay, or you shouldn't be using 3 integers. You should define an enumerated type. So again, this is the process of using Java the way it's intended to be used, which is the way you want to be with every programming language. Okay, so it's very easy to be a C programmer and come to Java and just write C code in Java and have it kind of work more or less, but that's not good. That doesn't help other Java programmers who are actually fluent in the language and how to use its properties to understand your code, modify it, and so forth. In fact, they'll just be irritated with you because they'll look at it and go, this guy just is clueless. Okay, so again, one of the things I want to emphasize in this class is getting comfortable enough with the language that when you have a particular concept that you want to express in code, you choose the right kinds of constructs in this particular language to express it. And that's what makes languages fun, because you can go to different languages and find that you can express certain problems naturally in a different language way better than you can in other languages. So, you know, for example, the Rubik's Cube thing, I used to teach 313, and I'd have them try to solve the Rubik's Cube, you know, puzzle block thing, and I'd have them do it in C++, and I'd have them do it in Lisp, and I'd have them do it in Prolog. And what they'd find is that when they finally got to Prolog and they did it in Prolog, it was like 1/10 the number of lines of code as in, you know, C++ or whatever, because Prolog turns out to be the rockin' language for solving those kinds of constraint satisfaction problems. Okay, so, you know, again, as you get more mature in software engineering, what you'll find is that you'll be presented with a problem, and eventually when you're presented with a problem, you'll say to yourself, geez, I wonder what language I should use for this one. What is the language that's going to make solving this problem as simple as possible? Okay, and so getting fluent in many languages helps you take that kind of approach to problem solving. If you're only fluent in one language, or you're kind of only vaguely fluent, like if you're really junk in Prolog, then, you know, it might take you as many lines of code to do it. You know, you've got to be good in Prolog to understand the, you know, the simple solution to the Rubik's Cube, you know, puzzle problem. Okay, so I want to encourage you to get fluent in Java this semester, and then next semester go get fluent, you know, in Ruby, and then the following semester go get fluent in Python. Get fluent in all, you know, as many different ones as you can. You know, add a functional language like Haskell or ML or, you know, Scala or something like that. Just, you know, that's a good one to add to your bag of tricks. Lisp should definitely be in there. You know, and actually, what's interesting is when sometimes you get fluent in a different language, and you'll come back to one of your earlier languages, and you'll realize that you weren't as fluent as you thought, because actually there's some capabilities there that you weren't aware of. All right, anyway, back to the lecture. Generic types, okay? So this is a very important part of the language, and something that when you're looking at old code, you'll see stuff like this all the time, where they're passing in a list, but it doesn't specify the type of objects in that list. And then they got these, you'll see this iterator object, and they're doing like this loop with has next, and it's just, and then you got to cast this next, the value returned by the next method to a string. You know, it's terrible. Okay, I mean, this was something everybody, including me, hated about Java, and it's a fundamental thing. My God, you're just iterating through, you know, a list, and look at that code. It's like horrible. Okay, so fortunately, so you know the problems. Fortunately, I'm going to go ahead. Fortunately, I'm going to go ahead. Come on, here we go. Fortunately, in Java 5. Okay, they fixed it, and they fixed it, I think, in a, you know, relatively elegant way, which is that now you have generics, and you can declare that the objects that is being passed in is a list of strings, and that right there, and it could be a list of a table, you know, of a hash set of a blah blah blah. You can have all sorts of embeddings and so forth, but you know, this is the simplest case where it's just a list of strings, and just this solves so many problems. Okay, first it solves the problem of passing in a list of integers or a list of something different. You can never do that anymore, right? The compiler is going to prevent, you know, this code. The code that's inside this concat method is now guaranteed that the list named list only contains strings, and that's super helpful. Second thing is now you can have much simpler syntax for your for loops, because you now know what the objects are inside your list. So you don't have to do any casting, you don't have those kinds of errors, runtime exceptions that can occur, and you have this relatively simple syntax. You know, ideally you really wouldn't have to say that it's a string element, because duh, you know, it is a string. I mean, and in fact in Scala it fixes that, so you don't have to type out the declaration, but you know, whatever, it's still pretty good. I mean, it's still quite good, actually. And in fact, you know, if this for loop is, you know, 100 lines of code away from this definition, then you might like having the string in there just to remind you of what the object is. Okay? So this is really nice, and now that you've seen it, let me go back. So the problems, there's type safety problems with the old code, the old ugly code here, because you could be passing in a list that isn't of the right types. And that will not show up at compile time, that will show up at runtime, which is not usually the good time to find out about your bugs. Okay. Also, it's the readability is a problem. So as a result, they define generics where you can declare the type of elements in a collection. Okay. Now the limitation, there are some limitations. Null is an acceptable instance, so you could have a null. Null is a instance of all types, so null could have been in that list, and that could kind of screw you up. And then whenever you interact with the outside world, of course, you never know what kind of type of object you're going to get. So you don't have kind of complete type safety forever and ever just because you have generics, because you're accepting things from the outside world, either from a socket or from a database or from the command line or a form or whatever. In that case, you got to kind of do some sanity checking or validity checking to make sure that the types are correct. But then from then on, it can all be good if you're using generics appropriately. Okay, so you can not only use generic classes that are predefined for you, you can also define them yourself. Those are a little more complicated to do, but it's still relatively straightforward. Here you say I want to define a class called numStack, and it's going to accept types of any type that is an extension of the type number. Okay, and then you can, inside your code, you write the code that supports any kind of type that satisfies this particular constraint. Okay, another kind of thing that people love to hate about Java prior to Java 5 was the fact that primitive types. There were these primitive types, int, float, double, etc., and then there were also the object versions, capital I integer, capital F float, capital D double, and you had to go through all sorts of conniptions to move back and forth between them. That really sucked. And in Java 5, they basically just solve the problem, because now there's this thing called autoboxing where you can go back and forth between primitive types and their object equivalents, and the compiler will do the right thing to make sure that the conversions occur. The problems with autoboxing are mainly that if you're trying to write code that is efficient, you've got some kind of low-level numeric computations, and you'll find that if you use autoboxing in the wrong way, that the code is going to slow down a lot, because it's going back and forth between the objects and the numbers. Now this, in practice, autoboxing is almost never going to be the reason why your code is slow. You're going to have something far more overwhelmingly wrong with your design that creates the slowness than a problem with autoboxing. But just to point out, I mean, it's not the case that this facility is completely free. It does create some runtime overhead, and so you do have to be in certain scenarios a little bit thoughtful about it. For me personally, I've never been in a scenario where I've worried about it in the slightest, because my problems were always at a much higher level, and my efficiency was not affected in any great way by this. Okay, so you can just see basically you can go back and forth between things like this capital I integer, which is the class or object representation of an integer, and the primitive non-object version of an integer, and there's no problems. Okay. Okay, then there's the annotations feature, which is an important. It's a metasyntactic property of the language, so it doesn't generally exist in the runtime code, okay, but it enables tools to do cool things to your system by virtue of the fact that you've added this annotation that provide information. What did I say? I mean metadata. What did I say? Metasyntactic? I don't know what I said. Okay. So for example, probably the most important annotation of all that you'll find in practice is @override. And this is when you basically, oftentimes you're going to have superclasses, and then you'll define a subclass, and you want to override a method of the superclass, okay? Which is a common thing you want to be able to do. The problem is, what happens if you misspelled, you define this new method which you're expecting to override, but you get the capitalization wrong, or you mistype a character or something. The problem is then you haven't actually overridden that other class. That other class does still exist in your class because it's been inherited, and so at runtime you're invoking that superclass method, and this method that you implemented never actually gets used because it's got the wrong internal capitalization or whatever. Okay, so the add override method solves that. If you take a method and you want it to be, you're intending it to override a superclass method, and you annotate it with at override, then the Java compiler will say to you, dude, you're indicating that this is supposed to override some superclass method, but it doesn't actually. Okay, and then you look and you go, oh my God, I forgot to capitalize that that interior R or Z or whatever, and then everything's good. Okay, so that's a really important one. The @test method is used by the JUnit tool to detect which methods are defined test cases, and so that enables that tool to work correctly. There's @guardian. There's a whole bunch of them. If you get into Spring and Hibernate, there's just uku bazillion annotations that some tools are really kind of annotation heavy in terms of using this particular facility. They're very simple to use, and we'll see them various places. Okay, so where I want you to go from here is to dive into Java in a nutshell, dive into effective Java. If you're in 4.13, you don't really have to dive into effective Java if you don't want to, but it's a great resource. If you're in 6.13, you definitely need to be reading effective Java. This lecture is to put you on notice that you will be running into code either in this class or outside of this class that is not written using these constructs, and so I want that to kind of send off an alarm bell when you see it. And if you're incorporating that code or whatever, you want to kind of upgrade it to modern constructs. And so for example, most of the robocode robots that you'll pull down from the net to play around with aren't written using this style. And so even though in certain cases you'll be incorporating pieces of other robots, behaviors or strategies, you cannot incorporate their old constructs. You need to use the new ones. Okay, that's all I've got. So live long and prosper.